All right, what's up guys? Mr. Fabella here, and today we're going to do another lesson, this time on surface area. More specifically, surface area of rectangular prisms and triangular prisms. So before we did surface area, So before we did area, so you should know how to find the area of a rectangle, parallelogram, trapezoid, triangle, and then we also did volume. So you should know how to find the volume of a rectangular prism and a triangular prism. So now those are kind of two different things, right? We're back to area, which is a two-dimensional measure. So how many little squares can you fit? But this time, instead of having the area on one flat surface, it is the surface area. So like if you had a box of cereal or something, how much surface do all 6 sides of that box take up? So that's what we're going to be doing. I'll try to do a demonstration later on, and I'll splice it in somewhere. But yeah, we're going to be doing surface area. So some of the uses of surface area is, the obvious one would be painting a room. So you would paint the room and maybe just ignore the bottom face, because most rooms are rectangular prisms. So you would find the total surface area of all the sides of the walls. If you're not painting the ceiling, that would be called the lateral area. So all the sides, what would the surface area be of that? If you were to print a box or make a box, surface area would be a good idea to find out how much material you would need. So like I said, we're going to find the surface area of a rectangular prism. We're going to find the surface area of a triangular prism. Sometimes it's hard to visualize if it's still in a 3-dimensional shape. So sometimes you can just pretend like you're cutting that box, because if you're making a cardboard box, it starts off flat, right? You cut it up and lay it flat. That would be called a net. And that's one strategy in finding the surface area of solids, is finding the net. So I'll show you both strategies. Okay, what's up guys? It's Mr. Fabella again, and now in my backyard with loud car noises. I thought I would do an example of finding surface area using a cereal box, because that's usually what the examples are that are given in the book. So I might as well actually do it. So I'm going to try to find the surface area of this cereal box and see what we come up with. Here we have frosted mini wheats. Yes, it tastes good to me. I don't know about you guys. Even the Trader Joe's version. So right now, if you see, there's like extra flaps here. We don't need this. So what I'm going to actually do is I'm going to tape up the top and the bottom so that I can actually make a net that you guys are used to seeing. Okay, so I taped up the top and bottom. Now I'm gonna try to cut it so it looks like the net that you're used to seeing. Okay, so now I have a box here, flaps up like that, the down, and then now I can have a net like we were talking about. So here, okay, so it might be hard to see, but there we have a net. So now I'm going to take some measurements. Okay, so the side is going to be 6.5, so I'm going to assume both of them are 6.5. Let's see, this is 9, which means over here this is also 9, and then there's only one more dimension I need to take, which is right here, and from here to here that's about, we'll say it's 11.5. So it's 11.5. So yeah, you can see this, if these fold together, see this is 6.5, that means this is also 6.5. So I don't have to take another measurement, but I'll write 6.5 here anyway. So, okay, so it was a little too sunny where I was. Surface area equals 2 times the base area plus the perimeter of the base times the height or the altitude. So the bases, I'm going to call these ones right here. So this base, the top and bottom of the cereal box, was 6.5 times 9. So, and then the perimeter is actually just all of this all the way across. So and then times the height. How far apart are the bases? Well, it's from here to here, and I estimated that to be 11.5. 415, and I measured all this in inches squared. So the surface area of this cereal box, if you needed to make one, you would need 415 square inches of cardboard Plus, you probably have to add a little bit because there are these little flaps here and here, and I cut them off at the top and bottom. But basically, if you had to make a guess, it would be 415 square inches. Or if you had to pay for like how much printing you had to do on it, that's how much ink you would need for it to cover. All right, so there's a real world example of finding surface area on this frosted mini wheats box. Okay, so I'm going to show you how we get the formula of finding surface area. So there's two ways to do it. So let's start with a rectangular prism because it's kind of the easiest way to do it. Not necessarily the easiest way, but kind of the way you're kind of used to seeing. So let's look at this. Let's make a rectangular prism here. And let's say it's 5 by 4 by 3. Okay, 5 by 4 is the base, 3 is the altitude, if you remember how to find volume, right? So separate surfaces, that's one way to do it. So I would look at the top and bottom first. So look at top and bottom. They flashed purple right now. So the top and bottom, to find the area of the bottom is 5 times 4. But since it's a rectangular prism, the top and the bottom are the same. So all I need to do is multiply that by 2. And that's 40 units squared. All right. Then I could look at the left and right. And it doesn't matter what order I'm doing this in. I could look at top and bottom, front and back, whatever. Left and right. If you see the left and right flashed orange, that's 3 by 4. So the area of left and right is 4 times 3, but left and right are exactly the same. So you multiply by 2 and you get 24 units squared. And then you guessed it, the last thing you need to find are the front and back. Again, the front and back are the same. They flashed green. 5 times 3. But there are 2 of them, so times 2. And that equals 30 units squared. Okay? And then now all you need to do is add everything up. This is almost like compound figures. And that's 94 units squared. Okay? So if that way like works for you and that's the only way you want to do it, then that's totally fine. But I want to show you a slightly faster way. Like most things in math, there's an easy way and a hard way. And a lot of times, the easy way is a little more tedious. So this is a lot kind of tedious, right? The way that I'm going to show you with nets is it's a little harder when you kind of try to get your mind around it. But once you know how to do it, it's faster. So first of all, you have to actually visualize what a net is to understand why this works. After you kind of see this, you can just memorize the formula and just do it. But it's better if you actually understand why using nets would work. So let's say we have this. So we have the front, right? The front, and pretend this box is unfolding. To the left of the front, that's the left side, okay? That's this part right here. If you fold it out the other way, that's the right side. So if you pretend the box is folding out here, here, and then the back is folded out even more. So this is the front, right? The right side, and then folded out from the back, that's going to be the back. And then where do you think the top and bottom go? It kind of doesn't matter the way you put it, but if we started off with the front, right? This top part can fold up, and this bottom part can fold down, which is what it's showing there. So now that we have that, now this is a two-dimensional shape. We can just solve this as a composite figure like we did before. So the way we do that is we have to fill out the numbers correctly. So the front, that base of the front was 5, and the right side, the height of the front was 3, right? The left and right side, that's 4, and then the back base is the same as the front, so that's 5. And then now you look at the top. So when the top folded up and the bottom folded up, that's this part right here and this part right here. That's what folded up and down, okay? So that means that would be 4. All right, so that's all the information you really need. That's all the information you need. So how would you tackle solving this composite figure problem? Well, I see one long rectangle and then 2 other rectangles top and bottom. So that's the way we're gonna do it. 2 times the bases, so 2 times the base area. Kind of like with volume, right? You did the base area times the altitude. This is take 2 of the base areas, because the base area is the top and the bottom. So you multiply those by 2. And then, this is the cool part, is that part, the base of this rectangle here, that's actually the perimeter of your base. Because if you think about it, when you're looking at your base, right here, this is 5, then 4, 3, and then 4 again. That's, or 3, 5, and then 4. That's actually the perimeter of your base. Because if you stretch it out, that becomes the perimeter. The perimeter is 18 times how tall is your figure. That is like the altitude or the height times 3. 2 times the base area, that's 5 times 4, which is 20, which is actually the same as this part right here. So this is why I said you're saving a step or two. So you still have to do that first step, right? But the perimeter is 18 times the height, which is 3, and that gives you 40 plus 54, which is 94 square units. So it actually did save you at least one step. Okay, so it says find the surface area of the rectangular prism shown to the right. So I'll do 2 examples. Whoops. I'll do a couple of examples. The first one I'll do with separate surfaces. Right? So surface area, I'm going to go top, bottom, left, right, front, and back. Okay, so let's see. Let's do top and bottom. That's here and here, right? That's going to be 2 times 9 times 7, because 9 times 7 is that top and bottom area. Okay, let's see, left and right. That's the right side is right here, right? And then the left side is right there. So that's going to be 13 times 7. And then there's the left and right, 2 of them, so times 2. And then finally, it's asking for the front and back. So this is the front. And I don't really need to do the back. Really, it's kind of hard to see. But the front and back, this is 9 times, and maybe it's hard to see because the 13 is all the way here, but if that's 13, this is also 13. So 9 times 13, right? And then there's 2, so times 2. Okay, so I got 126, 182, and 234, but those are separate surfaces, so I just have to add them up. So I get 542 square inches. Okay, so that's how much surface area I have on this rectangular prism. Just a real quick one, surface area of this rectangular prism, I said I would do one using nets, so I'll do one using nets as well. So if you recall, surface area is equal to 2 times the base area plus the perimeter times the height or the altitude. Okay, so let's see, you can decide whatever your base is. I'm going to say my base is this. Okay, so 2 times the base area, that's 6 times 2. Plus the perimeter, so the perimeter of the base. So the perimeter of the base is going to be 6 plus 2 plus 6 plus 2. That would be 16 times the height. So the height is the altitude, which is 3. Now I just need to multiply all this out. So this is going to be 24 plus, so 24 plus 48, that's going to be 72, and this is centimeters squared. So as you can see, that was already a lot faster, and that's me like talking you guys through this. Domingo built a toy box 60 inches long, 24 inches wide, and 36 inches high. He has 1 quart of paint that covers about 87 square feet of surface. Does he have enough paint? Does he not? Does he have enough to paint the toy box? Justify your answer. So let's see. First, we need to find the surface area. You could say, okay, this is 60 by 24 by 36. Okay, and then because I want to do it quickly, I'm going to find the volume using nets. Okay, so 2 times the base area plus the perimeter times the height. So my base area, I'm going to say, is this bottom part. So 60, so 2 times 60 times 24, okay? Plus the perimeter, which is 60, I'm gonna write it out because you might get confused. 60 plus 24 plus 60 plus 24, that's the perimeter, right? Times the height or the altitude, which is 36. So this is just like, these are big numbers, but that's kind of how real life is. Sometimes you get really big numbers. Okay, so now just calculate it. You can use a calculator. Okay, so I calculated that. I get 8,928 square inches, but that's not what it's asking. It's saying he has 1 quart of paint that covers about 87 square feet of surface. Does he have enough to paint the toy box? Justify your answer. Okay, so right here, it's giving it in square feet. So we have square inches. So let's first figure out 1 square foot. 1 foot squared equals how many inches squared? And you can't just say, oh, 12 inches squared. That's not the way it works. Because if you think about 1 square foot, right, that's 12 by 12. Because 1 square foot is 1 foot times 1 foot, right? So 1 foot is actually 12 inches by 12 inches. So 1 square foot is the same as 144 square inches. Okay, so that's another part of it. That means 1 square foot covers 144 square inches. So this covers 87 square feet. So I'm going to multiply this by 87. So that's going to be 12,528 square inches. That means that's more than the surface area of that toy box. So that means yes, because this is greater than or equal to. Okay, and so we did rectangular prisms. Why don't we check out triangular prisms? Here we have a triangular prism, and I'm going to use the shortcut way. You could also use separate surfaces by getting the 2 triangles up there and then the 3 rectangles. But if I want to do it faster, I get 2 times the base area. So you can see that the base is a triangle. Area of a triangle is 1/2 base times height. The base and the height are perpendicular to each other. So you have the 3 and the 4 and the 5. The 5 is not going to be used. The 3 and the 4 are perpendicular to each other, so those are the bases and the height. All right, so that's 1/2 base times height times 2. So that's kind of nice because the 1/2 times 2 kind of cancels each other out. And then find the perimeter of the triangle. The perimeter of the triangle, that's 3 plus 4 plus 5, okay? You can see that in the net, 3 plus 4 plus 5, right? Times the height or the altitude, and that would be 6. So then you just work everything out, fill everything in, right? And then you have 4 times 3 plus 12 times 6, and you get 84 square units, okay? The other way to do this is if you took separate surfaces. So you would still have this part, because that's the 2 triangles. But then this is even more work, because you have 3 rectangles there, if you notice, and none of them are the same. It's kind of easier when it's a rectangular prism, but if this is a triangular prism, none of those triangles are the same. So we can look at this front triangle, rectangle, and that would be 5 times 6, right, which is 30. And then you can look at this kind of like left rectangle over there, and that's 3 times 6. Okay, so that's 18. And then now you can look at this kind of right back rectangle, and that's going to be 4 times 6, okay, which is going to be 24. After you've done all that, that's actually 72. So the neat thing is, if you remember factoring, you see there's a 6 on all of these. So what actually happened is this 6 over here is kind of like factored out of 3 times 6, 4 times 6, 5 times 6. So this is kind of like also another proof of factoring and the distributive property in a way. Okay, so one last problem here. Brian's tent is a triangular prism. How much fabric was used to make the tent? Again, I'm going to use the faster way of using nets. So surface area equals 2 times the base area plus the perimeter of the base times the height or the altitude. So here, don't be fooled about what the base is. Remember when we did volume and 3-dimensional figures, a prism is named by its bases. The bases here are the triangles. This is a triangular prism. Okay, so the base is a triangle. So 2 times 1/2 base times height. So the base and height are 10 and 7 because 7 is perpendicular to 10. So 1/2 10 times 7. Okay, then the perimeter of this triangle. And it doesn't say this is an isosceles triangle, but we're going to have to assume that. My perimeter is going to be the 10 plus 8.6, because that's how tall this is. It's a little tricky the way this is drawn because the 7's here, but it's actually pointing to the height that's up and down over there. Okay, so 8.6 plus, and then this side is also going to be 8.6. And then times the altitude. So these are kind of tricky because there's height and altitude, there's another height. Altitude of a triangular prism is how far apart are the triangles. They are 12 feet apart. So this is 12 over here. And then now that's just a matter of using your nice calculator. Got stickers, okay, and then you just use a calculator. So you have 396.4, and this is in feet, so feet squared. Okay, so hopefully this was helpful on finding the surface area of rectangular and triangular prisms, and I'll see you guys next time.